Alright, so in this video, we're going to be going over problem set 11, chapter 17 material. So let's go ahead and get started. So we're given this aldehyde group here, and we're given these reagents. So in this case, the first thing we want to see is that this is kind of two steps. This is the first step here, the second step here. So the first step is basically we're going to add this methyl group across the double bond right here, all right, to the alpha beta unsaturated ketone. So it's going to, or unsaturated double bond aldehyde, not bad. That's going to add like this, right? But we're not done yet. The next step is to do the CH3NH2 with trace amounts of acid. And basically what this is going to do, it's kind of going to add this in place of this double bond oxygen right here. That's how I like to think of it. So it's basically just going to add a nitrogen and the methyl group here. Kind of just like sticking this right there. And that's going to be the final product. So the next problem is giving us this cyclohexane with a ketone, and it's having us add this NaCN as well as HCl. So the first step in this case is recognize that hint, remember the last problem set, react until the final product. So in this case, the final product is actually going to be this cyclohexane with this carboxylic acid. The intermediate step here is that on this carbon right here, it's going to form something like this where there is a nitrile group here and this group right here. But in this case, this is not the final product. We need to react it with H2O, HCl, and it's going to give us the final product of the carboxylic acid right here. All right, so next up, we have question 2 in the space below. We're doing mechanisms for the aldol reaction of butanol. So we have this aldehyde here, and there's two equivalents. So whenever I see something like two equivalents, I always like to draw them out just so I can kind of see what is going on visually. It's just really helpful. So the first step, whenever you have aldol reaction, is everything is going to react at the alpha carbon. So the alpha carbon is the one adjacent to the carbonyl carbon. So this is the carbonyl carbon, this is the alpha carbon. So the first step that is going to occur is we have this OH from the NaOH basically going to take this hydrogen off of this alpha carbon, and this pair of electrons right here is going to fall back down here, creating a negative charge. And basically that's going to form something that looks like this. All right, that's typically always going to be your first step when you're dealing with these kind of reactions. So the next step is we need to keep in mind that there's two equivalents. So there's this guy, and then basically this is going to react with this. So I like to draw it out. That's why drawing out is nice. So if you are kind of confused of where to go here, I think the charges is going to be your best bet. So over here, this is going to have a kind of partial negative, and this carbon is going to be really positive. And this negative over here that we made before is going to go ahead and attack this positive carbon, because like attracts like. And then if that comes here, these electrons need to go up here. All right. So then we're going to have this thing that looks like this. We have this oxygen, minus charge, and then we're going to basically add this group here. This stuff can be a little confusing, so if you have multiple colored like pens or something like that, that can be really helpful because it's really easy to lose carbons, and you're kind of forming this bond right here. So now we're going to get given this, but the reaction is not done yet. There's negative charge on this oxygen. And in order to get rid of this, we have this water from before. It's going to go here, take this hydrogen. This is going to collapse back down, giving us a final product that looks something like this. All right, and using highlighters or different colored pens and whatnot is really, really helpful. So we have something that looks like this. this originated from there, this originated from there. All right, this is a very, very important concept that I recommend you guys really study up, because this guarantee is going to be pretty high yield on this exam, as well as the final exam. All right, next steps, we kind of just have reactions, find the major product. So in this case, this is two equivalents. So we're kind of going to draw this out. This is the like an aldehyde reaction, kind of like before, but we're working with ketones instead of aldehydes. And the important thing to keep in mind here is that there's this heat heat group, which is going to condense the molecule all the way. So we have something like this: 1, 2, 3, 4, 5. We're gonna draw out the product. 1, 2, 3, 4, 5. It's gonna go down like this, and then we're going to kind of stick the rest of the molecule right here with the double bond because of the heat. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, forming this bond right here. Right, and the mechanism is very similar to the one we did in the previous question. Always reacting at the alpha carbon. All right, so our next reaction here, we have an aldol condensation type reaction. So in this case, we locate the alpha. Whenever you have something that looks like this, we want to locate the alpha hydrogen, the alpha carbon, and it's basically going to form a ring-like structure. We've seen this kind of reactions before. So this is the one of interest, negative charge. This is the positively charged one, or partial positive carbon that we mentioned before. This is going to kind of swing over here, attack here. And we have this, and the final reaction is going to be like this, kind of like how above we had to form a double bond. Same thing occurs here because of this this heat. Or normally it would be like an alcohol group coming out of there, but we're going to be condensing it all the way down. So this is the final product. All right, finally we have the Claisen reaction. Two equivalents. We draw them both out. And we're going to be reacting at the alpha carbon again. Typically, with these kind of guys, reacting at the alpha carbon is going to be your first step. And if we draw the mechanism out and everything, we're going to end up with something that looks like this. All right. Something like this, going to attack here, and follow a very similar mechanism from the previous kind of questions. All right, so now let's look at question number 4. So we're basically trying to form these molecules, this molecule and this molecule here. And we're starting with this guy, no matter what. So in order to do this, there's going to be a kind of pipeline that is typically going to always be true. So we're going to start with this guy, this molecule. And the first thing you always want to do is you want to react it with this NaOET and ethanol. So it's going to look like this. This is the reagent, NaOET, ETOH. And what that's going to do is that's going to form the negative charge at the, I messed that up, negative charge at the alpha carbon. Lazy, so I'm going to just write down ET. All right, so now we got this negative charge right here. In the next step, if we're trying to form this guy, we kind of have to add this big group here. In order to do that, this is going to react in an SN2 kind of reaction, all the way from OCHEM 1. All right, so we're going to count the number of carbons here. 1, 2, 3, 4, 5, 6, 7. And we're basically going to add one less on this haloalkene chain. 3, 4, 5, 6 with bromine. So you have 1, 2, 3, 4, 5. All right, that was a short one actually. 1, 2, 3, 4, 5, 6. So we're going to add one less of the carbons, and basically that is going to turn into this, and then this carboxylic acid group is going to arise from H2, H2O, HCl, and heat. So the intermediate here is going to look something like this. ETO, boom. And that's just basically going to react at the negatively charged alpha carbon. So we have 1, 2, 3, 4, 5, 6. As you saw here, 1, 2, 3, 4, 5, 6. Keeping track of all your carbons is going to be really helpful if you guys ever get lost. So finally, we have H2O, HCl, and heat. And basically that is going to, I like to think of just like getting rid of these guys and just leaving a carboxylic acid in its place, just for simplicity's sake. All right, so this is going to be your final product. Okay, let's do this one as well. Same thing applies. We're going to start with this molecule right here. Okay, in the first step, like we mentioned before, we're going to do the NaOET as well as the ETOH, ethanol, and that's going to form the alpha carbon negative charge. Like this. All right, so the next step is we have the carboxylic acid group here, right? We know that's gonna have to kind of arise at the very last step when we do H2O, HCl, and heat. That's just kind of a given. So now we need to figure out how to get these like carbon side chains on. So right here we have 1, 2, 3 carbons here, and 1, 2 carbons here. So we kind of have to do the SN2 reaction twice, once over here and once over here. So let's go ahead and do it. Let's go ahead and add CH3, CH2, Br, like before. Gonna make an SN2 reaction. And that's going to basically add right here. OET, carbon here, carbon here. It's gonna be these guys right here. But we're not done yet, right? We need to add the second alkyl chain. So in order to do that, we need to do the same thing again at the alpha carbon, because there's still a hydrogen on this alpha carbon here, right? So let's do NaOET, ETOH. And what that's going to do, ETO, and that's going to form, it's going to keep this intact. 1, 2. It's going to be a negative charge right there. Kind of similar from what we did in the steps above. And instead, in this case, we're going to add a 3 carbon long chain. All right, and it's going to add right here, OET. Pretty crowded, right? OET. All right, so now we have the final thing. As we mentioned before, we're going to react this with H2O, HCl, and heat. And that's going to kind of, what I like to think of, is just get rid of these guys and replace it with a carboxylic acid. And that's going to get our product. If I can draw this out, I might have added an extra carbon. I don't think I did. But yeah, this is going to be our product here. So I definitely review this. This is probably going to be covered a lot on exam 3. Thank you so much for watching.